So let's now talk about a large sample confidence interval for P when they don't give us all the information like they've been giving us. As always, we have to make sure a couple of things are clear, and that is that it is an SRS, otherwise the data is bogus. The sample size is large enough, and there's a way to decide that. But with proportion, the common rule is you have to have at least 10 successes or failures, and in some books they use 15. But the idea is that make sure you have enough successes or failures, otherwise it's not normal. Unlike earlier questions, now that we don't have some official numbers like the actual parameter and standard deviation, we have to create our own information. So this is much more real life and realistic. So you guys are familiar with writing an interval in plus minus form, and we've been doing that. But in AP, we talk a little bit more about formulas, and then we're going to use our TI as well. So all this notation is what you've been doing and what Stackey has done. So for example, P hat is something that you've already been able to create. You get a sample and you have a P hat. This M is what's called the margin of error. And the margin of error in AP is calculated with a Z star times what's called a standard error. And the standard error is calculated by this. So a lot of complex writings right there, but the idea is it's just breaking it down mathematically as to how they calculate these things and how Stackey works as well. So notice P hat symbol, N represents sample size. This is what's new, and that we'll figure out how to use in a second. So here's the question that we will apply this knowledge to. We are asked to calculate a 90% confidence interval for the population proportion of arthritis patients who suffer some adverse effects. So we have a confidence interval given to us, 90%. So that's where we would use Stackey, okay, with some information. But we're going to do it a little bit differently this time. The sample they get is 23 out of 440 people have adverse symptoms. So there's our P hat. Now this tells us the distribution, and the interpretation of this is just saying it's a normal distribution with a center or a mean of P and a standard deviation of this information here. So that's just basically stating the parameters and perspective of the question. So we're going to not really worry too much about that. So now we have some more interesting developments. So in our equation, they have a Z star, and a Z star is a number that they use for different confidence intervals. In the back of an AP book or a stats book, we have tables, and in this case, we would look at the table, and we'll get to that later, and you look for where it says 90% confidence, and it gives you a Z star. We also deal with 95% confidence intervals, and now it use this number instead as a Z star. And then 99 also has a value, and we'll show that later. But we want .645. So if we break down the formula, the Z star is given there, and M, if you remember, is our margin of error. These numbers come from our sample, our P hat. So probability of it occurring, which is our sample, the probability of it not occurring, which is 1 minus our sample, and this is our sample size, N. And that gives us a value of, or a margin of error of 0.023. So we have P hat and our calculated margin of error. So we can add and subtract 0.023 to 0.052 and get this confidence interval if we wanted to write it in standard form. Another nice way to do it is with a TI. If we go to a TI, I'm going to go up to our sample size there so we can see it. I would go, sorry about that, I would go on, hopefully it works, okay. I go to stat, I arrow over to test, and I'm going to go down to what's called a 1 proportion z interval, or 1 prop z int. I enter it. It gives me an x value, which is our numerator of our p hat, and 440, which is our sample size. I arrow down. This is numbers I put in for you already. I put in 0.9 because that's the confidence level, and I calculate. And that gives us something approximate, a little bit different than what they gave us because they calculated it a little bit differently with rounding and so on. But this is the same answer. So an interval between 0.034 and 0.069. Again, a little bit different than what is on our slide, but it is as good.